you for being here. And my name is Ray. I'm a developer advocate for the Google Cloud Platform. What that means is I like to bring some of our best technologies to developers all over the world, whether it's on Google Cloud or whether it's open source. And I love to also make our products and the Java experience better for Google Cloud Platform as well. And for that reason, if you have any questions, any feedback, any comment, please contact me on Twitter @Satanism. And because of that reason, I also started and work with engineers on the Spring Cloud GCP project. So if you ever use Spring Boot, you can find some really nice and easy to use starters so that you can try some of the GCP services very, very easily. And today I'm going to talk a little bit about microservices in terms of some of the issues, the cross-cutting issues that you're going to see. What I'm not going to talk about is the theories and why you should or you shouldn't use or go into the microservices architecture. You should always understand the pros and cons and also the complexity that's associated with the architecture to make your own decisions on whether this actually solves your problem. But if you do choose to go into this architecture, then there are a lot of other things you have to consider, right? Now, just a show of hand, how many people here are already adopting microservices architecture? Okay, a lot of people using like Netflix OSS stack kind of thing. Yeah, a lot of people are using that. Very cool. So we're going to talk a little bit about that. But first, there's something that's very fundamental I want to talk about, as the first thing. So there are many things that you're going to see when you break down a monolith into microservices, or if you start developing, just go into the services architecture. The number one thing that you're going to experience is, of course, rather than having just one application that you need to manage for multiple instances of that, now you have multiple components that you have to manage, and each one of them has multiple instances, right? Because every service, you don't run just one of them, you run multiple one of them for availability and scale and all of that. And now you really have a distributed system. However, the first thing that you're going to run into is to being able to manage and run all of these little instances, right? So it's more about a problem of deployment. How do you deploy so many instances around? How do you make sure they're always up and running? And in the traditional world, which I came from the Java world, we tend to run like one JVM per machine. And now if you have like 1,000 instances, you're not going to have 1,000 machines. So you're going to find ways to bin pack them into a fewer number of instances. And then what you're going to do is to kind of figure out how to isolate the resources so that if one of the application is taking up 100% of the CPU, it doesn't really step over other people's toe and causing a major outage. This kind of will trickle down, right? So there are a lot of things you have to consider when you start to run multiple service instances on a single machine. And of course, you need to deal with the networking, the port conflicts. You cannot have two JVM processes that always listens on the port 8080, right? Because then you have port conflict. So you have to manage the port, and then you end up with a spreadsheet with instances and which machine and which port and so on and so forth, right? Those are issues that you're going to run into. However, this is a solved problem. We have really good toolings for you nowadays. Whether you use a platform as a service or a container orchestration, we can solve a lot of these issues for you. How many people here are already using Kubernetes? Okay. Some of you are using Kubernetes to run your microservices, and other people are not. In case that's the case, maybe you're running into some of these issues today as well. We do have separate talks on Kubernetes in detail, but I'm just going to give a baseline overview here so that we really want to understand one fundamental concept. In Kubernetes, one of the most important things is the fact that you declare the state of your system in a definition, in a document, like a YAML file or a JSON file, it doesn't matter. But these are well-defined nouns and vocabulary that you can use to communicate with the Kubernetes server. And Kubernetes then is there to take this document and make that into reality. So in this case, in Kubernetes, you can tell it to deploy two instances of certain server. And Kubernetes will, go ahead and, you first push the image to a Docker registry, and you send this config file to Kubernetes. And Kubernetes is going to, behind the scenes, there's a little scheduler that's going to wake up to say, hey, do I have something I need to deploy? Oh, yes, I have something I need to make two instances of. And the scheduler will try to make the real state, the real world state to be the same as the one that you declared in the document, right? So Kubernetes will say, hey, I need 2 instances. Where can I run these 2 instances? I got so many servers. Which one actually has the capacity to run it? Let me go ahead and set up the networking for it. Let me go ahead and download the container image, and then we start the instance, right? And if one of these instances dies, Kubernetes will restart it for you, right? And also because we run them in containers, there's the networking that's being set up. So every one of these containers or pods in Kubernetes will have its own IP address, and so you don't actually have any port conflicts. And then we can set up load balancers and all that. All of these things are done with Kubernetes, right? So for example, here I have a bunch of Kubernetes definitions. Let me just open up one of them, and let's take a look at this one, right? So here I have a UI deployment. Basically, what I'm saying is I want to deploy 2 instances of my backend. In which backend am I going to deploy? That is in the name of the image, and this time I actually tagged it with the right version number 1.0, right? And then I just need to do like, hey, use the kubectl command line, not 3-piece, 2-piece. There we go. And I can apply all of these things. If I documented all of these desired state into a file, I can check them into my Git repository or CVS, whatever, or whichever that you use, right? And then you can deploy it, right? And when somebody want to change the state of the application, they just modify the file, check it into Git, and then from Git you have the CI/CD pipeline. Actually, just deploys the file. This is what they call GitOp, right? You always check in the state that you desire into a source repository. And if you apply it, this is what it's going to create, right? It's going to create, in here I'm running my Kubernetes cluster on Google Cloud Platform, one of the easiest way to run it. And here we have 2 instances of my front end, we have the back end, and so on and so forth. And each one of them has a unique IP, and also we have a load balancer, and we can actually go and take a look at it. And this time this is going to be on port 8080, and I can actually see the app, and I can say hello, and so on and so forth, right? This is a really, really easy way to manage and deploy services at scale, because Kubernetes cluster can handle like thousands of servers, and you can deploy thousands and thousands of pods or containers very, very easily. The most important thing here that I like to everybody to take away is that through the eyes of Kubernetes, each individual machine doesn't really matter anymore. Through the eyes of Kubernetes, I am just deploying containers, and Kubernetes figures out where to do that for me. So we can really see the entire cluster of machine with a single view, right? I just say, I need 3 containers. I don't care how many machines behind it is running it. And we do it through well-defined APIs and types and these nouns or these documents, these API documents, to define this desired state. And that's abstracted away from the underlying infrastructure. So for example, this particular load balancer, I define it as a service. That's a Kubernetes term. However, because I'm running on Google Cloud Platform, there's a little controller, a plugin, that will say this service will be mapped to a real load balancer behind the scenes. Okay? And which one? Well, because I'm on GCP, it will be a GCP load balancer. If you're on another platform, you will have another plugin that understands how to transform a service definition into a real load balancer on that specific platform. So in essence, you can think about Kubernetes, this is how I think about it, as a very traditional document management system, or an ERP system, so you will. I don't know if you ever had the experience with those systems where you enter a record and say, I need 5 widgets. You enter that into the document, and somewhere behind the scenes is a physical human being who goes out and physically orders the 5 widgets and ship it to your warehouse. In essence, that's what Kubernetes is doing behind the scenes, except that there's a script, there's a controller, there's a program that does this for you, right? So from the desired state, the document that you write, I need 2 instances. It gets stored in the Kubernetes master in a repository. And then behind the scenes, not a human being, but a controller wakes up and say, what do I need to do to make it into reality? And this is the separation between what we call the control plane versus the data plane. Because the control plane is really the resource that you are storing in the master node. And the data plane is the actual physical networking configurations that's conjured up and configured by Kubernetes so that I can actually make this call into my service. Okay? And so for that reason, if the Kubernetes master goes away, that is okay because the data plane or the serving path here with the networking with the IP, that is still there. Okay? So you give it a document, controller wakes up in the control plane, create something real that actually routes traffic, and that is the data plane. And that thing is going to come up over and over again. If you understand how this works, everything in the Kubernetes ecosystem basically works the same way. However, the other side of the problem when you are deploying a microservices architecture is really the fact that they are not communicating in memory anymore. So what that means is now you're bounded by the speed of your network, which is, depending on which network you're on, you have bandwidth, you have latency, and you have to consider two things. Number one is the language of the communication. Should I use JSON or should I use strict REST with JSON? Do I use RPC? Do I use RMI? Do I use gRPC? At Google, we use Stubby internally, and that is a RPC-style framework that's built on top of protobuffer. In the open source world, we actually can use something similar, which is called gRPC, which is really the next iteration of Stubby. So with gRPC, you can establish communication with the gRPC frameworks. You can talk to each other very, very efficiently, and it is all doing binary communication, right? It's all binary. And we handle, within our data centers, I believe we handle 10 to the 10 RPC calls per second, right? That's how much RPC calls we have to handle. Now, not everybody uses RPC. It's something you can look into. But maybe you're using JSON or SOAP. Anyone here use SOAP? Yeah. It's always around. It'll always be there, I think, right? So it doesn't matter. It doesn't matter because at the end of the day, nobody reads these documents. As a human being, the computers will deal with that, right? So how are you going to communicate? The second problem, though, is all of these other cross-cutting concerns. How are you going to load balance these calls, right? So one of the things I told you here is that Kubernetes can create a load balancer. Right? So every single one of these IP addresses is in fact a load balancer. It is true, except that it is a network load balancer. It's a L4 load balancer. What that means is once the connection is established, we will load balance that particular connection to one of the backend. However, every request that you make over that connection will always go to the backend that's connected to. So it is not a L7 HTTP load balancer, okay? There's a very, very big difference in between. What that also means is if you don't have enough connections, your requests are not going to be saturated enough to be evenly balanced across multiple backends. You may actually be stuck with one of the backends if you only opened up one connection, okay? Does that make sense? So you got to think about the load balancing here. However, one of the traditional argument about load balancing usually ends up with, do I want it to do on the server side or do I want to do it on the client side, right? It's proxy load balancing versus client-side load balancing. And there are pros and cons for each approach. For example, one of the biggest questions is, do you actually trust the client? Do you have control over the client? If you do, then maybe you can do client-side load balancing. Because for that reason, if you need to shift traffic from going to version 1 of your service to version 2 of your service, if you have the control of the client, you can update the client configuration and shift their server to the endpoint to the newer version of the service. But if you don't have the control over your client, like if you're doing, if you have cross-organizational clients or maybe somebody from the internet, from the mobile application, then you really want to deal with the proxy or the server-side load balancing, right? You want to route everything through a proxy, and then the proxy can do the load balancing for you. And there's, of course, a whole lot of other issues, like what if the backend is not there? How do you deal with fault tolerance? How do you do the retry? And one of the biggest things that I wish everybody will do when they have this architecture is the ability to look inside of exactly what is happening across the services. And for this, we call them observability, but basically just have some kind of distributed tracing and really, really good metrics about your services. Because if A is calling B and is calling C, if one of them goes bad, you need to know exactly which one of them is causing the issue, right? And there's so much more things that this cross-cutting concern that you have to deal with. And of course, in the open source world, we have really, really good client libraries and tools for you to do this, like Netflix OSS, which is really popular. And it allows you to deal with many of these cross-cutting concerns through the use of the library. So for example, if you want to load balance on the client side, you can use Ribbon. But then if you want to load balance on the client side, you need to know what's actually running the back end. So you need a registry. So you got to run Eureka. For resiliency, you're going to use historics, for retries and all that. And for distributed tracing, you use Brave or whatever, and you store the trace data in Zipkin and so on and so forth, right? There's a lot of good tools for you to do it today. But one of the things that you'll quickly realize, though, is that potentially your microservice, which is supposed to only deal with one thing and one business, whatever knowledge that you need to put into that microservice, now we're also building all of these libraries into our microservices as well to deal with all of the cross-cutting concerns. So now a microservice more or so became a microservice, right? There's a lot more things in there that we don't see, but our libraries are dealing it with for us. And then we need to run all of these other auxiliary components to make the entire architecture work and operational and all that. Now, all of these auxiliary components, you gotta have them, right? The gateway, the registry, and so on and so forth. But every one of these gray boxes also has to be made highly available. You have to manage them. You have to upgrade them, right? So now, if you're running a few services with all of these components inside, you're going to have a pretty complicated architecture to run your microservices environment, right? And sometimes this works, and sometimes there are other ways to do it. Especially, when it's easy, when you have a single stack, you have a single framework, like Spring and Spring Boot, which I love very much, right? It's very, very easy to set this up in one shot, right? It's very easy to do that. What's more challenging, though, is that if you have multiple stacks, if you're using multiple frameworks, if you're using multiple languages for that matter, what happens? Somebody says, hey, this task is really, really good for Node.js. So let's go back. We need to plug into this entire ecosystem. So for Node, I need to figure out how to do client-side load balancing. For Node, I need to know how to do circuit breaker. And now somebody says, I need to do something in Go. Well, you got to go back to this list again and deal with all the cross-cutting concerns, right? So it's become increasingly difficult in a large organization to be able to manage your microservices in a single coherent way. And it gets worse if you have legacy applications and so on and so forth, right? So these problems kind of grow organically as people are discovering that this is the architecture that they want to use. But at the end of the day, all we want to do is to make a call from A to B. A to B, that's all I care about as a developer, right? I want to make a call from A to B, probably over HTTP or a gRPC request or a HTTP2 request. That's all I care about. And this is where a service mesh comes in. A service mesh will lay down the foundations of ways to deal with these cross-cutting concerns for your microservices so that they just need to care about making that connection to an endpoint with a name, and we will take care of all of these other cross-cutting concerns for you, okay? And specifically, we're talking about Istio, which is a service mesh framework that is developed in open source with by Google, IBM, and Lyft. It's designed to run in multiple different environments. So for example, you can probably run Istio. You can run Istio in Kubernetes today. You can potentially run Istio in a Cloud Foundry installation, or maybe you can run Istio on bare metal or just VMs. And they can all tie up together with a fabric that can connect your services so that they only need to deal with a HTTP request. And service mesh will magically take care of everything else, right? That sounds a lot like a ESB, doesn't it? Anyone here had to deal with the enterprise service bus? Like, we promise you we can do the retry and the routing and dissect the messages and all that, and just one thing you need to do is to route everything through me, right? And that created a problem, and which is that you actually have a bottleneck with both deployment and also the amount of data you can actually process. And I can promise you, Istio is not like the traditional ESB. It is not the same at all, right? But in Istio, what we can do is we use the concept of Kubernetes where we have control planes. We can define, just like in Kubernetes, we can define the deployment state in these well-defined nouns. We can define the service-to-service communication needs in a separate set of nouns as well, a separate set of document. And through this control plane, we can then configure all of your applications to respect these rules that you define. For example, the routing rules, the retry rules, the circuit breaking rules, the performance monitoring, the tracing, everything. We can set all of these things up through a well-defined set of nouns. And then behind the scenes, there will be a controller that will wake up and make that into reality. And that's really what Istio can do. And there's really no magic, right? Sometimes when I first learned about service mesh, I thought, oh, that's really magical. How did they actually do it? So hopefully in this session, you'll get to learn about the details and understand why this actually works. So then if we are deployed on top of this platform, what that means is all these libraries that we used to include in the client may not necessarily need to be there anymore. Some of these things can go away. Some of these things might stay. But you can reduce what you include in your microservice. Secondly, all of these auxiliary services, they can be part of the platform rather than something that you manage. And we'll get into that in a second, right? And some of them will remain, but then we should be able to switch them out really easily, right? Just like Kubernetes, you can deploy on different cloud platforms. You can deploy on-prem. Similarly, for Istio, all of these service-to-service communication rules and the type of data you gather can be portable across different platforms and different backends as well. So where did this logic go? We cannot take away code and say everything still behaves exactly the same, right? Somebody has to do the work. So what happens then is we extracted all of this logic potentially from your client-side libraries into a dedicated proxy that will know how to deal with these cross-cutting concerns. And again, you might be thinking, oh no, a proxy, a single instance of that, right? Just like a ESB. But it's not. In Istio platform, we actually deploy a proxy instance for every one of your microservices instance. Okay, that is the one takeaway that you just got to remember. And we'll show you how that's done. The proxy that we're using is called Envoy. This is a proxy that's being developed by Lyft, a car sharing service in the States. And it's been battle tested in their production environment. So this proxy is very, very efficient. Now, it does not make sense to take away 80 megabytes worth of Java jar files and replace it with a 300 megabytes proxy. And so this proxy is actually really, really tiny, right? We don't want to, bloat out be too bloated, right? So these proxies are tiny. They're definitely going to be smaller than whatever that we used to include. And it's actually going to be efficient because it's actually written in C++. And this proxy can handle the load balancing, the TLS termination, the HTTP2 connections, the circuit breaking, and traffic splitting, and traffic shifting, whatever. Like all of the things that you will want in a cross-cutting way, we can handle this in a proxy. Now, the only thing is, we will deploy a proxy instance for every one of your microservices. And that is the key. But now, if you have if you have 1,000 proxies around, how do you actually configure it? This is where the difference between control plane and data plane comes in. The control plane is Kubernetes and Istio pilot. That is the controller. So you store a piece of configuration into Kubernetes. Istio pilot, the controller, will read this configuration and then propagate the configuration to all of the running proxies. Okay? So rather than maintaining the proxy in a central location like the traditional ESB, this is really just take the configuration and distribute it across your entire cluster, so every proxy will have the same configuration. All right? And behind the scenes, because every service has a proxy right next to it, this is done via Kubernetes, known as the Sidecar Pattern. So they are guaranteed to run together on the same machine. So rather than having to connect to the proxy over the network, this is actually a local connection to the local instance that's running dedicated to your instance only. So this connection is not over the network, and so it's actually very efficient. Behind the scenes, we also set up some IP table rules, so we intercept everything that's coming through. So everything that your microservice does that's going out will be intercepted by the proxy. Everything that's coming in will also be intercepted by the proxy. And that's how the service mesh works. And the proxy would have the configuration that you applied through the centralized configuration through Kubernetes, right? So microservice A makes a call to B. There's just the name. The proxy has the list of destinations for the backends through the Kubernetes service, through the registry. The proxy then is configured with the load balancing rule in terms of how this load balance should happen. Would it be least recently used? Would it be round robin? Would it be random? You can configure that. And proxy will pick out one of the backends and connect to it. On the receiving side, it will also intercept the incoming connection. And then it can do validation. It can say, can A actually talk to me? Should I accept this particular connection? Right? I can do a lot of checking before I forward the request to the actual destination. Okay? And the response will come back the same way. Right? That is exactly how a service mesh works. Now, if you look at this and compare it to what Java developer has been doing for a number of years, Matt Rabel once said, after watching this talk, once said that this looks like the aspect-oriented programming for microservices, right? We use AOP for a lot of the object-oriented stuff. We intercept all the incoming calls, and then we do magic to it. In a way, this is exactly the same. We intercept all the incoming and outgoing requests, and we can check against it before we forward it on, okay? So now you can ask really, really interesting questions. If you ever need to set up a retry rule, you can set it up in Istio, and you will go ahead and propagate this configuration to every one of these proxy, and now they all have the same retry rules. Okay? If you want to understand who's actually making the call to what, because everything goes to the proxy, we actually have all of those information and data. If you ever want to know how long did that call actually take, what is the latency? Well, the proxy knows when the call was initiated from microservice A, and it also knows when the response came back from B, and now we know latency, and we can aggregate the latency so that you have a full view of your deployment. And my favorite part of this is that if you ever are wondering how to connect and secure your connections over a untrusted network, how do you establish a mutual TLS connection for all of your services? Now, how many people here do Java development? Yeah, overwhelmingly. Okay, how many people here just love to deal with custom certificates in Java? Yeah, that's what I thought. Yeah, there's one, probably a specialist, right? So I cannot deal with that, right? The key files, whatever. It's just too much. So now, because these connections are all intercepted, this local connection here can be planned because they are on the physical POCs together. And the proxy can be configured by Istio with a special certificate just for this particular microservice application. And that can uniquely identify and authenticate itself against another service. And the proxy can do the TLS communication for you, and also it can actually validate the certificate for you before your microservice actually gets it. Okay? That is really the magic of all of these things tied up together. So why don't we go take a look at how this works. And just remember, Istio also abstracts away some of the underlying platforms. So maybe today you want to keep track of your metrics in Prometheus and visualizing in Grafana and keep your traces in Zipkin. Well, maybe tomorrow you're running a cloud platform. Maybe we can put everything and just change out the implementations. And now all of these data can go into a cloud service managed service, right? So you can do this without having to change your application, switching out like plugging and stuff. You can just switch it out within the platform. That is the vision of how this will work, similar to how Kubernetes abstracts away the underlying infrastructure. Okay, so why don't we just go ahead and take a look? Now I've been thinking a lot about how to best demonstrate this. Right, I want to demonstrate it as the simplest way as possible with a language that I like, and so I'm gonna be using Java. Of course, you can write a service very easily with Node and other things, but I love Java, so I'm going to use Java. However, some of the things here you should probably never use. Just say it out loud, right? I'll show you which ones. But anyways, so then I need to create two different services. One calls another, right? In the simplest way possible with no framework, okay? So I thought, okay, maybe I can make a work server, so some server that will do some work. And what is work? Work could just be a series of meaningless meetings that I go every day, right? So for that reason, I have a meeting server, right? So from the work server, I'm going to make a call to the meeting server. Very, very, very straightforward. Okay, so I'm going to also do this without any frameworks. So I'm going to do a few things here that you should probably never use. First of all, I'm using Java 9. And you should never use it because it's outdated, just saying, like it's end of life. So you should never use it again. The second thing I'm using is the Tsang HTTP server. which I don't know if you should use that in production. I never have done that before. So what I'm going to do is I'm going to create a new server here. So I'm going to say HTTP server create. I'm going to listen on port 8081. And there's a little backlog here, like a little buffer, which I need to do, right? And then I'm going to create this into a variable. And then all I need to do is to call server start. Okay, there's no dependency here. There's no magic. And then from the server, I'm going to just create a context. I'm going to listen on the meet endpoint. And then it's going to give me an exchange. And can use a Lambda to kind of handle this particular request. And I don't know about you, but if I go to a meeting, this is what I do. Yeah, there we go. Right? And of course, you're going to catch exceptions in case somebody wake you up and say, no, don't do that, right? And then if I successfully went to a meeting without getting fired and I slept through it, I'm going to say exchange.send response. I'm going to say 200 response. I survived. And I'm going to close the connection. And that's how you create a really, really simple server with just a JDK. There's no magic to it, okay? No magic to it. So I'm going to sleep for 250 milliseconds. Now, on the other hand, when I make that call, right, this is where things could fail. And because I plan to deploy this in Istio environment, I'm going to also use the simplest form of making that connection, which is through the new JDK HTTP client. Okay? And because of the time, what I'm going to do is something very special. Nobody else can do this. It's called reverse programming or backwards programming. And why do I code it that way? Somebody actually code this out. It's because I'm going to be typing the code in reverse. I'm going to go from bottom up. Okay, so there we go. I'm just undoing. Yeah, so anyways, I'm going to go to the meetings 4 times, right? And every time I succeeded here, I'm going to check for the status code. I'm going to say meeting ++. And I'm going to go ahead and create the client. This is all using the JDK 9 or the JDK client, the new one in the modules. And here's the important part. In Istio, you do need to make sure that the HTTP request, the connections, is actually HTTP 1.1. If you make a request with 1.0, you're going to get an upgrade connection request kind of thing, response, sorry. And that's not going to work, right? So you want to make sure that you set the version to 1.1. And then the most important thing here, the last thing that I want to call out, is that Istio can intercept all the requests for you and can examine the headers. And so if you want to do distributed tracing, Istio can trace your calls on behalf of your application. However, right, you're going to hear like Istio can do distributed tracing and all that, but they don't tell you the real thing you actually have to do, which is to actually capture the trace headers that Istio will generate. If no trace header is there, you have to capture it. If the trace header is not there, Istio will create a new trace header for you. It will actually create multiple trace headers like the request ID, the XB3 trace ID, the span ID, and so on and so forth. Okay, so Istio will generate all of these values for you. However, your application is responsible for propagating this on. If you don't do this, there's no way for Istio to understand request A is correlated to B, which is correlated to C. You actually have to physically do this. It's probably the most important part that you have to do. Now, if you're using Spring and Spring Boot, if you're using Spring Cloud Sleuth, that can actually propagate some of the headers for you. You just have to configure it to propagate additional headers. So if you're using Spring Cloud Sleuth, you automatically propagate most of the XB3 headers, but you can just configure it to propagate 2 additional headers for Istio, then you're good. Okay? So these 2 things are written, right? I can try this out. So, let me see here. So I'm going to run the work server and see if that works. Oh boy. I think that's running, I think. And let me run the meeting server as well. There we go. I'm going to start that. And I'm going to make that request. Wait a second. That's a Spring Boot application, wasn't it? One second. Let me stop everything. I think that is, there we go. See if I can just run this one. I just want to run this one, for example. So that should listen on port 8081. And then I'm going to run this one as well. That should be running on port 8080. Okay, it is running. Good. So I'm going to make a test. This is where live demo could definitely fail. So let me make that call. Right. So this is on my local machine. And if I do 8081 meet, okay, that's not bad. It actually made a call. And I can time it so that this is actually taking 250 milliseconds. And we can see that very clearly. Right. And I'm going to make another call to 8080 and let's do a /work. How many people think this would just work? Nobody. That's what I thought. All right. So let me see here. So if I do work, there we go. So we went to work. and for like a second and 200 milliseconds, and we went to 4 meetings, which makes sense on this particular host, right? So I can make that call again. Now, my question to you is, if I actually killed my work server, my meeting server, what happens? So let me stop the meeting server right here. If I try to curl work again, work is going to do what? It's going to make a call to the meeting server, and that's not there anymore, and you get errors, right? That's because we have no resiliency configured. This is just running locally on my machine. There's absolutely no magic here, right? So I just get an empty response. There's an exception, which I'm not seeing, but it's not working at all. But that's okay. We're going to go ahead and deploy this into an Istio environment. And the way we're going to do it is to first create the container. So there's no backup here. So let's see here. I'm going to go to the work server. I'm going to do a Maven. This is the best way to deploy to production, of course. Skip tests, yeah. And then I think it's a package, clean package, I think. And I have set it up enough so that when I'm doing the package, it's also going to build the container for me. So this is actually building the container, which I'm going to deploy in a second. Okay. So yeah, pushing container through this pretty awesome Wi-Fi today, which I'm pretty amazed. And I'm going to do exactly the same thing here. Now, while this is actually doing this, let me just show you another thing here. So these jar files, as you saw, is very, very minimal. There's almost nothing in there. And I call this a microservice because it's only 3.3K, right? So because of the fact that there's really no dependency, everything is on JDK. Now, of course, you may want to add more things to it, but just so you know, there's no magic, right? It's very, very baseline. So what I'm going to do then is to deploy this into my Kubernetes cluster, and I have written the deployment file here. If I open this up, you should be able to see that this is deploying from the container image that I just created. So I'm going to go ahead and just deploy all of these things very quickly. I have everything documented so I can just deploy in one shot. And it's going to talk to the Kubernetes cluster, say I need 2 instances of each, whatever, and I'm going to see whether they are deployed. Now, because these containers are really, really small, they should actually start up pretty quickly. So now I should have a meeting server and a work server. Now, without telling you too much, this is actually running in an Istio environment. Now, how did that happen? Well, if we go back to the deployment, here, this is a standard Kubernetes deployment file that only has a single container called the work server coming from my container image. However, during the deployment time, I configure my Kubernetes cluster with Istio already, and I enable something called the automatic injection. What that means is, rather than having just one container running here, we actually have 2 containers running as I deploy it. So when I deploy this deployment into my Kubernetes Istio cluster, behind the scenes is a little thing called the mutation webhook. You actually look at what deployment you are trying to do, and then add it and enhance it with the Istio configuration. Okay, that's all automatic. However, some people don't like magic, so what you can do is you can use a command line called Istio CTL, and then you can do something called kube inject, and then you can give it the file, like the deployment file. Now I'm going to do a less here so you can see what actually happened. This is exactly the same thing happens on the server side. So it's going to analyze the deployment file that I just created. However, if I scroll down a little bit, I can see this is the container I want to deploy. It also enhanced it with the proxy instance that's associated, that's dedicated to this particular instance. Okay, so this is done via a sidecar. So in Kubernetes, you can have multiple containers running side by side of each other. When one of them dies, the other dies too, and so on and so forth. Okay, they're tightly coupled together. And then if I scroll down even more, remember what I said, like how the interception happens? It happens when we set up the IP table rules to intercept all of the connections. And that is done through the Kubernetes init containers. So before any of those 2 other containers start, the init container is going to start first. And then from here, we set up the IP routing rules, okay? And so because all of these things are actually running in Istio, running in Kubernetes cluster, this is what I can do. I'm going to go ahead and shell into a demo pod. Exact. Let me see here, TI. So I'm going to go into my cluster. I'm going to go inside my cluster. I'm going to do a curl here to my work service on port 8080. I'm going to say work. Oh, wait, what? Did I know? Oh, work server. Sorry, work server. Whew. It's getting hot in here, isn't it? Yeah, I know. And I know it's not me, so, it's the computer. There we go. So, whew, it's really warm in here. All right, so So here is the attended 4 meetings here, right? And I can see that this is all going through. But remember, this shell, because it's running in a pod instead of Kubernetes Istio installation, when I make this request, it's also being intercepted by the proxy. Okay? And the proxy makes the decision on which backend to connect to. And this is all happening right now. So then, this is what I can do. I'm going to show a few things before I jump back into the slides a little bit. Okay, I want to make this public. I want to make this a public endpoint. So here, what I can do is in Istio, there's a concept called the gateway. A gateway is really just a publicly accessible IP address. And there's one already configured. Let me go ahead and find out what that is. So if I say kubectl get svc in the namespace of Istio system, I should be able to see the gateway, which is, where did it go? There we go, the ingress gateway. So that's the public IP address I can connect to. And it's going to be listening on port 80. Okay, so I'm going to zoom out here a little bit. So I'm going to curl this URL on port 80. Oh, you can't really see it, can you? There we go. And it's going to say connection refused. That's because I haven't really set up the gateway yet. Okay, so first thing I need to do is I need to apply this gateway. Now remember, these are Istio nouns, and behind the scenes, there's a little controller that will make this becoming a reality. So once I configure this gateway, it will be configured pretty soon. However, there's one more thing I need to do, which is I need to set up a virtual destination or what they call a virtual service to bind the URL, right? So what this is doing is to say, I am going to listen for certain URIs. You can match on many different things like the URI, the headers, the few other things. And I'm going to bind this on the gateway. And you can also listen on a virtual host as well. So if you're running on different organizations with multiple different domain names, you can also bind to a specific domain name as well. So let me go ahead and apply this. Again, remember what happened behind the scenes. Oh, not that one. A little controller will wake up and make this becoming the reality. Right? So hopefully I can go ahead and say, go to the work destination. And there we go. So now the gateway, the Istio gateway has been configured. This is the proxy that fronts everything for external traffic coming in. Right? So now I can do this, right? And I can put this into a while loop as well. I'm going to say while true. And I should be able to see that I'm going to work. And this version of the work I'm doing is just going to 4 meetings. Right? What I can do then, this is all intercepted by Istio. So one of the things I can do, of course, is to mess around with this proxy. I can apply different configurations. And one of the things I like to do is to have fun at work. And this is the rule I can apply, which essentially is a chaos monkey, except that there's no such chaos here. We're going to abort 100% of the traffic with a 503 error. Okay? So remember how this works again? Just reiterating that. I'm going to go ahead and do VS. I'm going to apply this rule. Goes into Kubernetes, configure all the proxy, configures the data plane, and now all the responses are 503. And if somebody says, haha, that's too funny, like, can you please, like, we're trying to get to work, right? Then you can go ahead and just delete it, right? That is the foundation of how all of these things work. If I apply this configuration, I delete it, we're back to normal, right? And through this mechanism, we can do many, many different things. So for example, if I have multiple versions of my application running, let me see here. Let me just apply V2. So we're going to deploy another version of me who works really, really hard. What that means is I go to 8 meetings a day, for example, right? So this backend is being deployed, and eventually we're going to see the run robin here. There we go. So you can see working really hard as version 2, and working normally, which is 4 meetings. Now you might be saying, Ray, wait a second, it's not 50-50. Well, it is. Every request will be 50-50 chance. So over time, it's going to converge a little bit, right? So 50-50, well, that's fine. Then what can I do? Well, then I can actually shape the traffic per request by configuring my load balancers. And the way I can do that is that, well, first of all, I need to define what the 2 versions are. And this is done by defining a destination rule with a subset. So you can group different backends into different subsets based on the version, for example. And the subsets are grouped by like the Kubernetes labels. So one of them has the version label called latest. The other one has version label called 2.0. So I'm going to go ahead and apply this subset. So I'm going to say, you know what? I'm going to group all my backends into 2 sets based on labels. Right? So now I have V1 and V2. And then what I can do is to say, you know what? Right now, I want Istio to route all the traffic to v1 subset rather than the v2. So I can define a route rule here to say for 100% of the time, I want to route it to v1 rather than v2. Again, all I need to do is to apply this configuration, vs v1, for example, and watch what happens, right? It was going to 50-50 chance, going to working really hard to working, not so hard. And now 100% of the time, I'm going to v1. Of course, if I want to change it to v2, I can just modify the configuration, apply it through Istio, and we'll reconfigure your proxies, and it will do the right thing, okay? That's how this thing actually works. And there's a lot more things you can do. So for example, if you ever want to set up a retry rules, you can. So for example, if you want to set up a, what do you call it, the retry rules or circuit breaker rules, all you need to do is to define these retry rules. You can do this across your organization or for a specific service for that matter. For example, here I can say specifically, if we're connecting to the meeting service, you should be retrying 3 times. We can configure that. Right? So everybody who comes in to make this connection will have this retry rule and so much more. Now, here's the magic. You saw that the app has no framework. It's just making a regular HTTP. The only thing I'm doing is really just passing the trace header. But you get a lot out of this whole system. So for example, if I want to see the metrics, remember, the proxy has all the latency. So that's automatically ingested by Prometheus right now. What that also means is I can visualize it in my Grafana dashboard that is installed by default in a Istio sample deployment, right? So I should be able to go in here and go to Grafana dashboard. And I should be able to go in and find my maybe my service dashboard. I don't know exactly which one. Oh, there we go. I think the connection here is just like, So there are some things here that I need to change. So for example, here maybe I can look at the work server. There we go. And then I can see the QPS that's coming from my application right now. If I want to see the meeting server, I can just go there, right? And oh, check this out. You can actually see the little time span which I set every response to 503, right? All of these are automatically collected and exposed from the Envoy proxy as part of the Istio installation. Now there's even more. So for example, if I want to have a real view into who's actually making the call, there's this little utility called the service graph, and you can also connect to that. So if I go to the service graph here, this is actually extracting near real-time information that's being collected from Prometheus, and we can actually see, for example, the actual service calls that's taking place at the HTTP request level. So this is actually pretty cool. So you can see all the different services here and who's actually making the call to what. You can, of course, make this a little bit prettier so you can actually see it more clear, right? So this is something that's definitely possible. However, one thing that I really like is that just by passing the trace header around, you can look up the traces now in Jaeger or in Zipkin or on Google Cloud for that matter, right? So again, I have no magic in my code. If I go here to the Jaeger console, let me see here. I should be able to find the different services I have running in my cluster. This is all automatic, right? So I can go to the work server and I can find a few traces. And oh, check this out. So I found a trace, and here I can see all the calls that I made. And you can actually see that it went to the work server first, and then we made 8 meeting requests after that. And for each of the requests, you can also go in and see the latency around that, okay? And just remember, the way that it works all behind the scenes is because we intercept everything, right, from the proxy, and then we expose everything via the platform so that you can get the centralized view and a centralized control over your microservices deployment. There's definitely a lot more things you can do, but I want to jump back to the mutual TOS part. Hopefully now you see how this actually works with mutual TOS. So through Istio Pilot, and also you can install a Istio certificate authority, we can assign a temporarily generated certificate for all of your proxies so that they can mutually authenticate with each other. And we'll also automatically rotate them out frequently so that they will be rotated out like in hours or something, so that you don't have to do that yourself. Okay? Whew. So it's really hot in here. So just remember, I think I only have a minute left, right? With Istio, It is an open source project. If you lay this on top of Kubernetes cluster, then you get a lot of things for free, basically from Istio platform. That you can control your traffic, you can control your load balancing rules, you can control the resiliency rules like retries and circuit breaker rules. You can also enforce policy. So if I have the certificate, then I know for sure who's actually making the call. Then I can enforce rules to say, no, like microservice A, you cannot call the HR service or you cannot call the financial service because you are not authorized to do it. You can define all of these things directly as an Istio rule as well. Okay? And that's pretty much it. And if you want to find out more, please check out the Istio.io community page. And the reason I'm here is that Istio is 1.0 now. So you can try this out. And if you have any feedback, any comment, please participate in the community. And if you want to see in more detail on how the source code works, if you want to follow through a code lab, you can find it on my link on suddenlism.me. And you can find a lot of materials there as well. And thank you so much for being here. Thank you. It's really warm in here. Thank you for sticking around in such a warm room here. I really appreciate it. Yeah. If you have questions, I'll be on.